Hey y'all, what's up? Today we're going to do multiplying and dividing rational expressions um, and simplifying them. So that's our SWABAT. But first, you definitely have to know what a rational expression is before you know how to multiply and divide them. So that's what we're going to do first. And a rational expression, all it is a quotient or a fraction, same thing, of two different polynomials. Remember what a polynomial is? X to a power plus x to another power plus, okay, you get the point. One example might be x squared plus 1 over x cubed minus 2x plus 3. An even simpler example might be 1 over x. What about something crazy like 7x to the 55th minus 4x to the 30th plus 3x all over 2x to the 5th minus 4x plus 5. You could also have something in factored form, like this. 2 times x minus 1 times x plus 2 times x minus 4 all over x plus 1 times x minus 1. That is also a rational expression because those are all polynomials. Non-examples include things that are not polynomials. So maybe like the square root of x over x squared plus 2 plus 1 plus, I don't know, something, 2. Or maybe you have a negative exponent or something, because that's not a polynomial. Or maybe it's like a number to an x, because that's not a polynomial either. That's an exponential. Those would all be non-examples. Those are all not polynomials in the numerator and denominators, and therefore not rational expressions. Alright, so question 1. How do you simplify rational expressions? Well, it's really similar to simplifying fractions. So say for example we have 12 over 64. If you break up 12 into all of its factors, and you break up 64 into all of its factors. So I'm going to start by breaking up 12. 12 I'm going to start with as 2 times 6. And then you could break that up even more if you wanted to. If you go all the way down to the prime factorization, which is every single factor that you have is a prime number, then it's really super easy to simplify. So let's finish that for 12. So 12 would be 2 times 6, which is 6 is 2 times 3, so that's 2 times 2 times 3. And then let's look at 64. 64 is 8 times 8. And then 8 is 2 times 2 times 2, or 2 cubed, or 4 times 2. But let's go all the way down to the prime factorization. So it's going to be 2 times 2 times 2 is the first 8, because 2 times 2 times 2 is 8, and then the other 8 is 2 times 2 times 2 as well. Okay, so we've broken down all of those both of those numbers into their prime factorizations. So then you've got 2 times 2 times 3 over 2 times 2 times blah, blah, blah. You can cancel out, as long as it's all multiplication, you can cancel out a 2 and a 2, a 2 and a 2, and then you're left with 3 over 2 to the 4th power, okay, which is 3 over 2 to the 4th, which is 3 over 16, right? 2 times 2 is 4 times 2, another 2 is 8 times another 2 is 16. Okay, so that would be our fraction simplified, and hopefully that's just a refresher, hopefully. If not, come see me. We should go over that. Okay, so then we move on to actual rational expressions. And we would do it kind of the same way. So say for example I've got 4x to the 5th over 5x squared. Okay, I want to break that up as much as I can. And I've got 4x to the 5th, so that's 4, and eventually, you know, this will be easier for you, and we won't have to go through every single step. But just for now, just so that you have it, 4 times x to the 5th is x times x times x times x times x, 5 x's, right? And 4 is actually 2 times 2. Well, we could write that as 2 times 2. Then in the denominator, I have 5, which is already prime, so I can't break it down anymore, times x squared. So that's an x times an x. Okay? And so you just cancel anything that you can. So there are no 2's in the numerator and denominator, so we can't cancel those out. We can only cancel out an x and another x. And then we're left with 2 times 2 times x times x times x over 5. So that then becomes 4 times x cubed over 5, which you can also write as 4/5 x to the third. Yeah! Okay, then we go to the next problem. Simplify x minus 1 squared over x squared minus 1. Okay, now this, remember, you need to have it in factored, prime factorization, so it's got to be in its factors. If you multiply the first one out back into standard form, as in x squared, you do x minus 1 times x minus 1, don't actually do this, that's x squared minus 2x plus 1. You now have everything with addition. And when you have addition in a fraction, you can't cancel anything out because multiplication and division are inverses and they cancel each other out, but addition and subtraction don't work with division. Okay, so anyways, so instead of putting it into standard form, you want to put it into factored form. So the first one, the numerator, is already in factored form, and so we just want to write the bottom in factored form. Okay, so x minus 1 squared is x minus 1 times x minus 1, so I'm going to write it out like that. And then x squared minus 1, that's a difference of perfect squares. You remember how to factor that? Hopefully you do. That is x minus 1 times x plus 1. Okay, and then you can cancel out any factors, because look, you only have multiplication and division. So I can cross out an x minus 1 and an x minus 1. And I'm left with x minus 1 over x plus 1. Whee! Okay, so here's the thing. If you have a rational expression, that means you have something in the denominator. And denominators cannot equal 0.
Did you divide by 0? Yes.
Can't do it. Okay, so you gotta figure out if at any point in the problem the denominator is 0, you cannot have that number in your domain at all. So you have to say, hey, by the way, x cannot be these numbers. So for example, in the first example, right, at one point you had an x in the denominator, an x squared. So you have to take the denominator, 5x squared, and say that cannot equal 0 ever. So solve for it. Divide by 5, take the square root, whatever you have to do. You get x cannot equal 0 for the first example. For the second example, you've got x squared minus 1 in the denominator. That cannot equal 0. So we solve like we would solve a regular equation. X squared cannot equal 1, and that means that x squared x cannot equal plus or minus 1 for the second problem. Okay, so make sure you keep that in mind as you're solving these problems in the future and for the rest of your life. Alright, multiplying rational expressions. Same thing as multiplying fractions. You multiply straight across the top and multiply straight across the bottom, and then you can simplify. Or you can simplify first and then multiply straight across. It doesn't really matter what order you do them in. So when the numbers are really big, I would recommend simplifying first before you multiply, like in this 40 times 35 over 60 times 49, because those are some nasty numbers. So I'm going to write 40 as 20 times 2, because I can see ahead. 60 I'm going to write as 20 times 3, and 35 I'm going to write as 7 times 5, and 49 I'm going to write as 7 times 7. So first and foremost, I want to cancel out some of those big numbers. So 20 and 20, and the 7 and one of the 7s. So now all I'm left with is 2 over 3 times 5 over 7. And then to multiply fractions, you just multiply straight across. So that's 10 over 21. If you can reduce it any more, do so. But in that case, nothing else you can do. Alright, so with rational expressions, first you got to figure out when is the denominator 0, because it cannot be 0. And if I'm looking at my denominators here, I'm only going to have denominators with 0 when x is 0 and when y is 0. So I'm going to say that in the beginning. X cannot equal 0 and y cannot equal 0. And then I'll do the rest of my work. Alright, so I look at my first fraction and I see an x squared and an x cubed. And since everything's multiplied, I can cancel out 2 of the x's from the numerator and denominator. So an x squared I cancel out of the numerator, and in the denominator, since I have x cubed, I'm left with 1 more x. Okay, so then I have a new problem, 2 times y to the 5th all over 2x. Oh, hey, look at that. We have 2 2's as well. We can cancel out our 2 2's. Oh, man, I love simplifying. Okay, so now we have y to the 5th over x times x to the 4th over y cubed. And then we multiply these fractions just the same way we multiply our regular fractions. So we do y to the 5th times x to the 4th. I'm just going to put my x first just because I like alphabetical order. And then x times y cubed. And then, hey, look at that. I can cancel out even more. So I have an x to the 4th over x. One of those cancels. So this becomes an x cubed, and that goes away. And then if you're not sure about that, you can write them all out. X to the 4th is x times x times x times x. And then you have divided by x. So you just cancel one of them out. You're left with 3 in the numerator. And then out of the 5's, you can cancel 3 of them. And you're left with 2 in the numerator. So I'm left with x cubed times y squared. And I've canceled everything out of the denominator over 1. So my final answer, x cubed times y squared. But remember, x and y cannot equal 0. Last but not least is dividing rational expressions. Same thing as dividing regular fractions. Copy the first one and then multiply by the reciprocal, right? I like to call it copy dot flip, but I know a lot of you guys are just like, oh, multiply by the reciprocal. So here you go. So we multiply by the reciprocal. So I've got 14 times 6 over 3 times 7. And I say, hey, don't simplify because don't multiply them out because you want to cross your factors out. So let's break down 14 into 2 and 7, 6 into 2 and 3, and then we can cancel some things out before we go to our final product. And by product, I mean the thing that we're making, which is a quotient. I can cross out a 7 and a 7, and a 3 and a 3, and I'm left with 4. Woohoo! Same exact thing for rational expressions. You copy the first one, change to multiply, and multiply by the reciprocal. And then we just multiply straight across. 3x to the 4th times 3x squared is 9x to the, add the exponents, x to the 6th. And then I've got 2y to the 4th times 4y to the 5th, and that equals 8y to the 6th. There's nothing you can cross out, so that's your final answer, but make sure you say denominator cannot be 0. So y can't be 0 and x can't be 0, because when we started, we had a y in the denominator and an x in the denominator. Alright, for our second example, we cannot have 0 in the denominator. So again, figure out where your denominator is 0. Alright, so setting both of the denominators equal to 0, you get x cannot equal plus or minus 1. So that's your initial restriction, but make sure as you go through, like you can never have a 0 in the denominator. So you might find some later. Next step, factor everything. Factor the numerator. X squared minus 7x plus 12. Factors, you need to find out what multiplies to 12 and adds to negative 7, and then factor this x squared minus 1 as well. Okay, now you gotta multiply by the reciprocal. At this point you need to say, stop! Because now if x is 4 or 2, you have a 0 in the denominator. So those are also restrictions. And now we just multiply straight across and simplify. I repeat, do not put into standard form until after you've simplified everything. So now you can cancel out an x minus 1, an x minus 4, and you're left with x minus 3 times x plus 1 over x minus 2. Pause now, try number 1, and then check your answers. Bam! See you later!